Mid-February 1943. Sidi Zid, Tunisia. The desert wind rolled across the dunes as a captured M4A1 Sherman tank ground to a stop in the sand. Its American white star, still faintly visible beneath a freshly painted black German cross, marked a strange sight. A U.S. tank now under German control. Officers from Heavy Panzer Battalion 501 gathered around it with notebooks in hand, studying their unexpected prize. This single tank, captured intact and fully operational during the fighting around Sidi Bouzid, would trigger a quiet crisis among German engineers, a reckoning that rippled through their armored vehicle programs for the rest of the war. What they were about to learn would challenge the foundations of their design philosophy. The coming revelations would not concern superior armor or more powerful guns, but something Germany had never truly prioritized: automotive reliability, the ability of a machine to simply keep running, no matter the conditions. Painted across the hull in white letters was a name: War Daddy 2. Its serial number read USA 3067641, built by the Lima Locomotive Works, assigned to Company G of the 1st Armored Regiment, 1st Armored Division. German reconnaissance troops drove this tank over 350 kilometers of North African desert to the port of Sfax, a journey that took 4.5 days. Every kilometer revealed something unsettling to the Germans. The engine never overheated. The transmission didn't jam or slip. The final drives held steady across the scorching terrain. German tank crews, accustomed to frequent breakdowns even on short moves, watched in disbelief as this American machine rolled onward without complaint through terrain that routinely crippled their own panzers. At the port, War Daddy 2 was carefully loaded onto a freighter bound for Germany. The German Army Weapons Office sent explicit orders. The vehicle must reach the testing grounds at Kummersdorf intact and operational. Intelligence analysts had read reports about American tank production, but now, for the first time, they had one of the machines themselves, living proof of the statistics they had once dismissed as propaganda. The Sherman represented not just a tank, but an entire philosophy of engineering and manufacturing that Germany could not match. It was a product of industrial maturity, of factories built for mass production, run by a workforce trained in automotive assembly. The ship carrying War Daddy 2 steamed north across the Mediterranean as Wehrmacht engineers prepared testing protocols designed to expose every detail of its construction. None of them yet realized how profoundly this single tank would challenge everything they thought they knew. Spring 1943, Kummersdorf Proving Ground, Brandenburg, Germany. The captured Sherman rolled off a transport rail car bearing a German license plate, WH058941, and the test designation, Zugfahrts 259. Across its hull, engineers had already stenciled precise armor measurements and angles. This was no ordinary inspection. The German Army's proving ground, located 25 kilometers south of Berlin, was the heart of the Reich's technical evaluation program. Here, captured Allied vehicles were examined down to the smallest bolt. Teams of specialists from multiple technical departments surrounded War Daddy 2. They photographed every component, measured every clearance, and annotated every weld seam. To their eyes, American construction seemed almost too simple, straightforward to the point of crude. But as they began testing, simplicity proved to be the Sherman's greatest strength. The transmission immediately drew attention. Where German tanks used straight-cut gears that demanded tight tolerances and constant maintenance, the Sherman featured herringbone cut gears, a design that spread the stress across multiple teeth, dramatically improving durability. In Germany, such gears were considered too complex to produce in large quantities. Yet the Americans had been mass manufacturing them since the 1930s, turning them out by the thousands. The testing began with automotive trials. Engineers drove War Daddy 2 through obstacle courses simulating battlefield terrain, measuring fuel consumption, engine temperature, and drivetrain performance under heavy load. After each trial, they disassembled components to inspect wear and lubrication. Every result contradicted German doctrine. The Sherman performed adequately in mobility and handling, but excelled in one area that stunned its evaluators: operational endurance without maintenance. It kept running again and again, without requiring the constant mechanical attention that German tanks demanded. The Sherman's 5-speed synchronized transmission offered another revelation. Gears 2 through 5 were synchronized, eliminating the need for double clutching. In practice, that meant the tank could be driven almost as easily as a civilian car. American crews required minimal training. German tankers, by contrast, spent weeks learning complex gear manipulation to avoid damaging their transmissions. The Americans had designed their tanks for ordinary soldiers, not mechanical experts, a practical approach Germany had never embraced. The Continental R975 radial engine further impressed the testers. It ran consistently across wide temperature ranges that would have overheated Maybach engines. Its cooling and filtration systems were simple yet efficient, shrugging off dust and sand that had crippled German vehicles in North Africa. Every system reflected the same underlying philosophy: function over complexity. June 6 to 7, 1943, Hillersleben Artillery Range. Albert Speer, Reich Minister of Armaments and one of Hitler's most trusted industrial managers, arrived to oversee a major demonstration for senior officers and industrial leaders. Alongside the newest German designs, a freshly built Panther OSV and a Ferdinand tank destroyer, stood the captured Sherman War Daddy II. The demonstration aimed to highlight German technological superiority. But what unfolded told a different story. The Sherman climbed the test slope smoothly. Its synchronized gearbox shifted effortlessly. The engine maintained steady power. The driver maneuvered with confidence, showing how easy the tank was to handle. Next came the Panther. Its 700 horsepower Maybach engine gave it more raw power, but even with all its strength, it struggled to match the Sherman's ease of control. Then the Ferdinand, a 65-ton monster, attempted the hill. Halfway up, its complex electric transmission failed, and it stalled. Crews rushed to restart it in front of Speer and dozens of officials. The embarrassment was impossible to ignore. Speer later admitted that American tanks showed cross-country mobility German engineers had never achieved. In his 1944 inspections of Italy, he noted that Shermans could climb mountains previously thought inaccessible to armored vehicles. Reports from the 26th Panzer Division confirmed that the Sherman's power-to-weight ratio gave it superior mobility even on level ground. A week later, the Das Reich newspaper cautiously praised the Sherman, calling it a noteworthy product of the North American steel industry. The article highlighted its serial production methods and even acknowledged its gyrostabilized gun as a pioneering innovation. Though the language was restrained for propaganda reasons, engineers knew what it really meant. The Americans had built a tank that not only worked, it thrived under real battlefield conditions. Behind closed doors, Speer's ministry circulated quiet memos warning that U.S. automotive engineering represented a decisive industrial advantage. The panic spreading through German technical offices had begun. By mid-1943, War Daddy II had become one of the most studied machines in Germany. Reports, blueprints, and component sketches circulated among the highest levels of the armaments ministry. Every subsystem, from the powertrain to the suspension, told a story of a manufacturing culture entirely alien to German industry. At the Hillersleben testing grounds, the Sherman had humiliated the Ferdinand and exposed the over-engineering of the Panther. The Americans, the Germans realized, had not sought perfection in every part. They had sought consistency. And consistency in war was worth more than elegance. The German Army Weapons Office compiled its findings in a thick technical dossier titled Versuchsbericht über amerikanischen Kampfpanzer M4A1 Sherman. It summarized what the tests had revealed. The mechanical reliability of this American tank surpasses our own vehicles. Its components are easy to replace and built with tolerances that permit extended operation in field conditions. That single paragraph carried the sting of heresy. German engineers prided themselves on precision, on craftsmanship so fine that it bordered on art. Their tanks were built by specialists, adjusted by hand, and tested individually before delivery. In contrast, the Sherman was a product of mass production, parts interchangeable across thousands of vehicles, assembled by workers who might never have seen combat. For the German technicians at Kummersdorf, the implications were alarming. If the Americans could produce tanks in such quantity and maintain this level of mechanical reliability, then German superiority on the battlefield was doomed. Meanwhile, on the front lines, the German army was already feeling the consequences of its design philosophy. The Tiger I, introduced with great fanfare, suffered from chronic drivetrain failures. Final drives burned out after just a few hundred kilometers. Gearboxes cracked under stress. The Panther, hailed as the future of armored warfare, proved fragile during its combat debut at Kursk. Of the 184 Panthers deployed, nearly half broke down before reaching the front. The lessons of War Daddy II spread quietly through the technical branches, but the cultural divide remained. German officers refused to believe that simpler could mean better. Their engineering doctrine valued maximum theoretical performance, even if it meant maintenance headaches in the field. The Americans, on the other hand, had built a tank to function under chaos. The Sherman's radial engine could run on multiple grades of fuel. Its transmission tolerated rough shifting. Spare parts were interchangeable across variants. It could be repaired in hours using standard tools. Every aspect of its design acknowledged a brutal truth. Wars are not won by perfect machines. They're won by machines that keep moving. One German test engineer recorded in his report, "The American tank can be disassembled in a fraction of the time required for a Panther. Many parts are standardized to an astonishing degree. It appears their production methods have reduced the skill requirement for assembly and repair." That statement alone terrified the German ordnance bureaucracy. The Americans had effectively industrialized battlefield logistics, a concept Germany could not replicate with its decentralized manufacturing system. June 1943, Stuttgart, Daimler-Benz headquarters. Albert Speer convened a meeting with senior engineers from Maybach, Mann, and Henschel. The agenda: discuss the results of the Sherman evaluation and their implications for ongoing tank programs. Speer began bluntly. "Gentlemen," he said, "we have built marvels that cannot be maintained." He held up a folder containing the Kummersdorf test summaries. "The Americans have built the opposite, a machine that works." There was an uncomfortable silence. The engineers knew he was right. Germany's production lines were slow, fragmented, and dependent on scarce materials. Precision machining bottlenecks limited output. Every Tiger tank required over 300,000 man-hours to assemble, more than 10 times that of a Sherman. Speer urged the companies to simplify designs, to adopt modular manufacturing, and to consider standardized components. But his plea came too late. The Wehrmacht was already locked into its production commitments. The Tiger II and Panther G were deep in development, both far too complex to be retooled for simplicity. As one Maybach engineer reportedly muttered after the meeting, "We are designing masterpieces for museums, not machines for war." The shock of the Sherman's reliability reached even Hitler's inner circle. Field reports from Italy and North Africa confirmed that American armor units could sustain continuous operations far longer than German formations. Shermans rolled forward while Panzers waited for spare parts or recovery vehicles. Speer's field inspections in Italy in 1944 reinforced this grim truth. He noted that Allied tanks operated deep into mountainous terrain, regions German staff officers had deemed impassable. The Sherman's ability to climb, maneuver, and sustain movement in such conditions contradicted every assumption the Wehrmacht had about armored warfare. In one inspection report, Speer wrote, "The enemy's vehicles demonstrate a degree of cross-country mobility that exceeds our own. The Americans have achieved in practice what we considered impossible." By late 1943, the German Armaments Ministry could no longer ignore the implications. The Sherman wasn't simply a tank. It was a symbol of American industrial power. Its design philosophy, prioritizing function, reliability, and production efficiency, reflected the same mindset that had filled U.S. skies with bombers and its seas with Liberty ships. The German analysis concluded that American tanks represented a synthesis of industrial mass production and practical field engineering. The words were carefully chosen but unmistakable in meaning. The Americans had mastered the art of making war machines at scale. The irony was that the Germans had the expertise to build reliable vehicles. They simply refused to. Before the war, their automotive industry produced some of the world's most dependable trucks and cars. But wartime pressures and Hitler's fascination with superweapons had driven them toward excess. Each tank became a showcase of mechanical ambition, over-engineered, overcomplicated, and underbuilt. The Sherman's success exposed the cost of that arrogance. At the Kummersdorf grounds, War Daddy 2 continued to run test laps month after month. Its engine hours piled up with minimal maintenance. Mechanics intentionally stressed the drivetrain, ran it hot, and clogged its filters with dust to simulate desert conditions. Still, the tank ran. In one late report, the test supervisor summarized the findings in understated but damning language. Under operational conditions, the American M4A1 displays superior reliability to domestic armored vehicles. Maintenance requirements are minimal. The vehicle is designed for sustained field operation without workshop support. That sentence was quietly circulated among a select few, stamped with Geheim, secret. It would not appear in public documents until decades later. But within the German engineering community, it was enough to provoke an identity crisis. The Sherman had done something no battlefield encounter could. It had exposed the limits of German engineering pride. By late 1943, War Daddy 2 was more than just a captured tank. It was a silent teacher. Each run, each test, each gear change added another layer to the uncomfortable truth confronting German engineers. The Americans had built a machine that was simple, durable, and efficient. The Wehrmacht's own designs, though formidable on paper, were faltering under the weight of their own sophistication. At Kummersdorf and later Hillersleben, engineers from the Heereswaffenamt, the Army Ordnance Office, kept the Sherman running under increasingly punishing conditions. They pushed it through mud tracks, cross-country climbs, and sand pits, often running the engine for days on end. Despite deliberate neglect, the tank refused to quit. Mechanics noted that even when components showed wear, they could be removed and replaced in hours. The German evaluation teams began to draw comparisons. While a Tiger or Panther might require a full maintenance crew and specialized tools, the Sherman could be serviced in the field by ordinary soldiers. Its parts fit together intuitively. Its bolts, threads, and fittings followed logical standards, the kind used across American vehicles and machinery. It was, in a sense, the embodiment of interchangeability, the foundation of industrial warfare. One Kummersdorf engineer summarized his findings succinctly. The Americans have engineered for use, not for admiration. Their tank is not perfect, but it works everywhere. To the German technical mind, trained to equate precision with excellence, this was an alien concept. Perfection was a cultural obsession. From the delicate mechanisms of a Leica camera to the complexity of a Maybach engine, German craftsmanship sought refinement at all costs. But the Sherman's effectiveness showed the limits of that philosophy. The Americans had aimed not for flawless performance, but for reliability under the worst possible circumstances: mud, dust, fatigue, and chaos. The engineers dissected the tank piece by piece. They examined the vertical volute spring suspension, simple, robust, and easy to maintain. Each bogie could be removed independently without disturbing the others, allowing field repairs in hours. It lacked the sophistication of German torsion bar systems but matched them in function and far exceeded them in ease of upkeep. The Ford and Continental engines drew similar admiration. They weren't exotic, but they were forgiving. The radial engine of the M4A1 could run even when damaged, and its cooling system rarely failed. German engineers tested it against their own Maybach HL230. The result was sobering. The American engine required a fraction of the maintenance hours and tolerated greater operational stress. Even the fuel system caught their attention. The Sherman could run on lower-octane fuels, a huge advantage in wartime logistics. The Maybach engines demanded high-grade gasoline that Germany increasingly struggled to supply. The Sherman, meanwhile, ran on whatever was available. When Albert Speer reviewed the compiled reports in early 1944, he saw more than just technical differences. He saw an industrial philosophy gap. The Americans had achieved strategic reliability. Every tank produced was part of a vast ecosystem: factories, depots, supply chains, and repair facilities, all synchronized for continuity. In a meeting that spring, Speer addressed a small circle of engineers and generals. The Americans have mastered the art of reproducibility. Their machines are not built by craftsmen but by systems. Systems we cannot yet duplicate. It was a confession few in the Reich wanted to hear. The Nazi propaganda machine had spent years insisting on the technical superiority of German arms. But now, within the walls of the Armaments Ministry, it was clear America's strength lay not in genius designs, but in industrial discipline. The irony was stark. Before the war, Germany had been a world leader in mechanical engineering. Yet wartime mobilization had fractured its efficiency. Competing design bureaus, redundant production contracts, and endless customizations crippled consistency. No two batches of tanks were ever truly identical. Meanwhile, American plants like Chrysler's Detroit arsenal rolled out hundreds of Shermans every week, each one virtually interchangeable with the next. Speer recognized this as the heart of Germany's problem. He urged simplification across the industry, even drafting memoranda to streamline tank production. But the change came too late. The war's trajectory had already turned. Allied bombers were decimating German factories, and raw materials were dwindling. The Wehrmacht would never be able to replicate the American system. By summer 1944, War Daddy 2 had become a benchmark for everything German tanks were not. The engineers at Kummersdorf continued to document its performance even as Allied armies pressed toward Normandy and Italy. In one late entry, a test officer remarked, "This vehicle remains serviceable after repeated trials. Its ease of control allows any driver to operate it effectively." The Sherman's 5-speed synchronized transmission remained a source of fascination. German drivers, used to wrestling their gearboxes into submission, found it effortless. The Americans had used a Borg-Warner design with helical gears, smoother, quieter, and far more forgiving. The test drivers noted that even with minimal training, one could drive the Sherman without damaging the transmission. By comparison, Panther and Tiger transmissions required constant attention, with clutch adjustments and lubrication schedules that demanded skilled mechanics. The Germans had built sports cars. The Americans had built trucks that happened to carry cannons. And in total war, trucks won. The Sherman's gyrostabilized gun also intrigued the German evaluators. Though primitive by later standards, it allowed the gunner to keep the barrel roughly on target while moving, a revolutionary concept in 1943. German tanks, by contrast, had to stop to fire accurately. Engineers dismissed the stabilizer as imprecise, but some privately admitted it gave the Americans a tactical edge in fluid engagements. In propaganda, the German press continued to downplay these findings. Articles in military newspapers praised the Sherman as a useful but inferior design, emphasizing its weaker armor and armament. But behind closed doors, the reports told another story. The Americans had optimized their tanks for the reality of war, not the ideal. The influence of War Daddy II extended far beyond its time. Long after the war, when German engineers began designing the Leopard 1 in the 1950s, the lessons of the Sherman quietly resurfaced. The Leopard's emphasis on mobility, maintainability, and reliability owed as much to the M4A1 as to any German wartime design. The Leopard's designers deliberately avoided the mechanical excesses that had plagued the Panthers and Tigers. They built for field serviceability, easy access to components, standardized parts, and a focus on consistent performance. In a sense, post-war German tank design finally adopted the principles the Sherman had demonstrated in 1943. It's remarkable that a single captured tank, a machine built by American factory workers thousands of miles away, could shape the future thinking of the very engineers who once dismissed it. War Daddy II became an unintentional mentor to those who would rebuild Germany's armored legacy. At the end of 1944, the Kummersdorf report on the Sherman concluded with a simple yet profound observation. The American approach to production and operation represents the triumph of practicality over perfection. Its lessons must be heeded if we are to compete in modern warfare. But by then, Germany no longer had the time, materials, or stability to act on those lessons. The Allied advance was relentless, and the factory's spear had worked so hard to reorganize were burning. In its final months of service at Kummersdorf, War Daddy II was still running. Test drivers joked that it might outlast the war itself. They weren't wrong. By the beginning of 1945, Germany was collapsing. The Reich that had once spanned from the Channel to the Volga now stood cornered within its own borders. Allied bombers roared overhead, cities lay in ruins, and what remained of the Wehrmacht was retreating on every front. Yet deep in Brandenburg, at the Kummersdorf proving grounds, one foreign-built tank still rumbled to life each morning, a weathered American Sherman nicknamed War Daddy II. The same tank that had crossed the Tunisian desert under German control 2 years earlier now continued its slow, mechanical duty, starting, running, enduring. Its olive-drab paint had long since faded under layers of German markings and test data scribbled across its hull. The mechanics who cared for it, many now young recruits or aging technicians, joked that the American machine was more reliable than the electricity in their workshops. They weren't far from the truth. While Panthers and Tigers sat immobilized by shortages of fuel or spare parts, War Daddy II still drove under its own power. It had become something of a myth among the engineers, a symbol of what Germany had never managed to achieve, an armored vehicle that simply worked. Throughout early 1945, Kummersdorf's staff continued to collect data, even as Soviet artillery began to thunder in the distance. By now, the testing reports were less about discovery and more about documentation. The war was clearly lost, but the engineers still believed in preserving their findings for whatever came next. In one of the final Kummersdorf memos, dated March 1945, the chief engineer summarized 2 years of Sherman evaluation. This vehicle demonstrates consistent mechanical endurance despite extended operation and limited maintenance. Its construction reflects a deep understanding of practical field requirements. We have learned much from it. There was no bitterness in the words, only a quiet recognition of respect. For all their pride in German engineering, these men knew they had been outmatched by a philosophy of function over form. As Berlin prepared for its final defense, the Kummersdorf staff began evacuating materials and test vehicles. Some were destroyed to prevent capture. Others were abandoned along roadsides as fuel ran out. But War Daddy 2 was spared. The engineers had grown oddly protective of it. They siphoned what fuel they could find to keep it mobile, hoping to drive it west and surrender to the Americans rather than be overrun by the Soviets. Whether the tank ever made that final journey remains uncertain. After the war, Allied technical teams scoured Germany for surviving test reports and captured equipment. Among the documents recovered at Kummersdorf and Hillersleben were detailed files on U.S., British, and Soviet vehicles, including a comprehensive analysis of the M4A1 Sherman. The Americans were astonished to find how extensively their own tank had been studied. They discovered that War Daddy 2 had logged hundreds of hours of operation under German testing, far more than most tanks experienced in combat. Its endurance had, in its own quiet way, proven the philosophy behind American design, that reliability and standardization were weapons every bit as potent as firepower. The German reports were later translated and archived by Allied intelligence. Many of their conclusions would resurface in post-war military studies, influencing tank development not only in Germany but also in the United States and Britain. In the following decades, as NATO rearmed and West Germany rebuilt its defense industry, those lessons took root. The new Bundeswehr required machines that could operate under sustained conditions, across varying climates, and with minimal maintenance. When Krauss-Maffei and Porsche engineers began developing the Leopard 1 in the 1950s, their guiding principle was clear: simplicity, mobility, and reliability. The Leopard's design was a far cry from the mechanical labyrinths of the Tiger and Panther. It was light, fast, and easy to maintain, a deliberate inversion of wartime excess. Engineers later admitted that they had studied Allied wartime philosophies, particularly the Sherman's field performance. In their pursuit of the ideal post-war tank, they had, in essence, followed the American playbook discovered through War Daddy 2. In the years that followed, historians pieced together the scattered remnants of the Sherman's German service. Photographs from Kummersdorf showed the tank with test markings, armor angle annotations, and German registration plates. It had been used for demonstrations, mechanical trials, and comparative studies. A few blurry images show it lined up beside a Panther and a Tiger, a quiet reminder of competing worlds of design. The fate of the actual tank remains a mystery. Some accounts suggest it was captured intact by advancing Soviet forces in April 1945 and later shipped to Moscow for inspection. Others claim it was destroyed in the chaos of evacuation. No confirmed record of War Daddy 2 has ever surfaced after the war. Yet its influence far outlived its steel. The technical findings drawn from that tank shaped German understanding of mass production and practical engineering for decades to come. It wasn't a matter of admiration, it was a reckoning. Albert Speer, writing from his prison cell after the war, reflected on this bitter irony. In his memoir Inside the Third Reich, he acknowledged that American and Soviet production capacity had overwhelmed Germany not only in quantity but in efficiency. "We built good weapons," he wrote, "but the enemy built enough of them, and they built them to last." That observation echoed the same truth the Kummersdorf engineers had learned from the Sherman, that a war machine's true genius lies not in its sophistication, but in its ability to endure the everyday brutality of battle. Today, historians and armored vehicle experts still reference War Daddy 2 as a symbol of that turning point. It represented more than a captured tank. It was the moment Germany confronted the consequences of its design philosophy. For a nation obsessed with precision, the Sherman was an insult to perfection. A crude, mass-produced machine that simply refused to fail. The Germans had called their tanks Kunstwerk, works of art. The Americans had built tools. And in war, the tool outlasted the artwork. In hindsight, War Daddy 2 stands as a quiet monument to the power of industrial pragmatism. Its story reveals how a single machine, seized in the chaos of North Africa, could ripple through enemy engineering circles and rewrite their understanding of what mattered most in mechanized warfare. It wasn't speed or armor or firepower. It was reliability, the unglamorous virtue that kept armies moving when everything else broke down. When modern tank crews in the German Bundeswehr climb into a Leopard 2, a machine celebrated for its balance of firepower, protection, and reliability, they are, in a sense, sitting atop the lessons once learned from an American tank tested at Kummersdorf 8 decades ago. War Daddy 2 may be gone, but its legacy endures in steel, doctrine, and design. A quiet echo of an age when a captured enemy machine taught Germany what its own brilliance had overlooked. In the end, the Germans had tested a tank. But what they discovered was themselves.